Welcome back to the GCSE Maths Pro YouTube channel. Today's video is on finding the lowest common multiple, or otherwise known as the LCM. So if you've seen the previous two videos in this series, we've been through prime factor decomposition and also the highest common factor. If you haven't already seen both those videos, go check them out now. I'll have them linked down below in the description. But before we jump into it, I do find that a lot of students aren't really sure on what the LCM is, or just easily get it mixed up with highest common factor, lowest common multiple. They might know what both of them are, but just get the two mixed up. If you're happy with already knowing what it is, then feel free to skip forward to the next chapter. We'll start going through the questions. So I'm just going to break down the lowest common multiple into pieces. First of all, we need to know what multiples are. A lot of people focus on the word lowest, but actually in terms of highest common factor and lowest common multiple, the key part is, in this case, multiple. So multiples are numbers basically found in the times tables. So what I mean by that is, for example, 50 is a multiple of 5. So in this case, multiples are normally bigger than the actual number itself. So you've taken 5 and we've multiplied it to get 50, okay? 25 is also a multiple of 5, 30 is a multiple of 5, things like that. Then if we look at putting together common multiples, so normally with highest common factor and lowest common multiple, they give you 2 or 3 numbers, don't they? And they say find highest common factor or the lowest common multiple. So common multiples is basically from our 2 or 3 numbers that they give us, which numbers do they all have in their times tables? So the numbers that 2 or 3 other numbers all have in their times tables. Now that's a bit cryptic, but for example, 50 appears in the times tables of 5 and of 10. Okay, so it's in the 10 times tables and the 5 times tables. So they have that multiple in common. And then we're going to put on the lowest. So this is where a lot of people get confused as well, and I've explained it in the previous video. A lot of times we focus on the word lowest and go, yeah, okay, the lowest common multiple is like the smallest number, the number that's smaller than what you're looking for. No, it's actually, of all of your multiples, if you list down all the multiples that they both share, it's the smallest one. Now, your lowest common multiple is still going to be likely to be bigger than the numbers they've asked you to find the lowest common multiple for. So it's the smallest multiple both numbers have in their times tables. So for example, 10 is actually the smallest multiple that the 5 and 10 times tables both have. So while 50 is a common multiple of 5 and 10, it's not the lowest common multiple. Now explaining it in terms of words and using words like this is still a bit complicated, so we're actually just going to go through, do some questions so you can kind of get an idea of what I'm actually talking about. As we said with highest common factor, there's 2 ways of doing this. The first one is lowest common multiples. So what we're saying is, of the times tables, so of the 12 times tables and the 15 times tables, when is the first point that they overlap? So the first way you could do it is, if you want, is just list out the times tables. So for example, 12, 24, 36, 48, and so on until they overlap. 60, 72, 84, and on. And then I do the 15 times tables, 15, 30, 45, 60, 75, so on. You can see that the common multiple is 60, and that's the lowest one, isn't it? That's the first multiple that they have in common. So you go, okay, therefore, the lowest common multiple is 60. That's one way of doing it. That's absolutely fine if you want to do it that way. My issue with doing it that way is that with 12 and 15, they're very small numbers, so that's actually fine, isn't it? You know the 12 times tables, and the 15 times tables aren't really that hard to figure out, and especially if you have a calculator. It's when you start getting much bigger numbers. And also, I only had to write down, 3 or 4 of the times tables. You might end up not finding the lowest common multiple until you've gone through 10 of each of the times tables. So, especially if it's a non-calculator test, I wouldn't necessarily recommend doing it this way if the 2 numbers are much bigger than 12 and 15. So I'll show you the other way that you can do it. And this is just down to personal preference, okay? It's up to you which version of the method you prefer. If you haven't seen the video on product of prime factors or prime factor decomposition, I'll link it here. Definitely go watch that first, because I'm not really going to explain that part of the method, but we're building on that, and we did the same with highest common factor as well. So what you can do, the other option is you can break down both numbers into the product of their prime factors. So I normally start with 2, 3 and 2, so that one's 2, 2 and 3. 15 is a bit easier, 5 and 3. Now I've got it on the next page anyway. What you then do is draw some Venn diagrams. They don't have to look nice like this. You don't have to use a compass, just kind of scribble out 2 circles and label them 12 and 15 in this case. And we're going to do exactly the same thing as we did with the highest common factor. So if you've seen that video, you'll know what to do. Any numbers that they have in common go in the middle. So if you look at this list, you see how they both have a 3. So I'm going to put 1, 3 to represent that pair. Now they actually don't have anything else in common. So for the 12, there's 2 2s left over, and for the 15, there's a 5 left over. Now for highest common factor, we looked at just multiplying any numbers in the middle. For lowest common multiple, it's actually the whole of the Venn diagram now that I've filled it out correctly. So the lowest common multiple is all of that, and you multiply them together. So lowest common multiple in this case is 2 times 2 times 3 times 5. Now you might be thinking, well, isn't it just all these numbers times together originally? It's actually not, because do you see how they had 2 3s, but I only wrote down 1. So whatever's in the middle is a pair. You're only going to write it down once. And then you just work that out. So 2 times 2 is 4, times 3 is 12, times 5 is 60. Obviously that's the same as what we just got because we worked it out in a different way. Okay, so that's another method. Now I would use this method for when you have much bigger numbers. It's completely your choice whether you want to do it this method with the Venn diagrams or whether you want to use the method where you just list out all of the times tables. The only problem with this is if you miss one out, you get it wrong. If the numbers are huge and you end up listing like 20 other numbers, if you don't have a calculator, that one can be quite hard. The Venn diagrams method might seem long, but once you've got into the flow of it, it's actually quite fast. So let's try another one. For example, in this case, it says find the lowest common multiple of 40 and 75. Now, yeah, you can list out the multiples of 40 and the multiples of 75. If I don't have a calculator though, let's say this is non-calculator, I might not want to have to figure out the 75 times tables. It's up to you, but I'm just going to do it using the Venn diagrams method. So I'm going to break them down into the product of their prime factors. So I normally start with 2 just to keep halving it. Okay, so that one's 3 2s and then a 5. 75 is obviously not an even number, so I can't start with 2, but I'm going to start with 5 because I know it ends in a 5. 5 and 15, 5 and 3. So I've got 3 and then 2 5s. Okay, as you can see, I've got that listed here. Now, scribble out your Venn diagrams. To fill them in, first of all, we always start with the middle. So what do they have in common? Well, in this case, they actually only have 5s in common. So that pair of 5s, I'm only going to write it down once in the middle, okay? And then for 40, I've got 3 2s, and for the 75, I've still got a 3 and a 5. Once I've done that, I just need to multiply together all of the Venn diagram. So the lowest common multiple is 2 times 2 times 2 times 3 times 5 times 5. If it's a calculator test, obviously type that in. If it's not, you'll just have to work it out yourselves. This one's quite long, so we've got 2 times 2 times 2 is 8. Then we've got 25. 5 times 5 is 25, times 3 is 75. So 8 times 75. I guess this one is more likely to be a calculator one because it's a bit longer. But that should give me 600. So you can see 600 is quite a big number. Imagine having to write out all of the 40 times tables up to 600 and all of the 75 times tables up to 600. Personally, I would rather not do that, especially if it's a non-calculator paper. And doing the Venn diagram method also means that you'll definitely get your working out marks as well. So the lowest common multiple of 40 and 75 is 600. If you feel like you're starting to get the hang of it, obviously feel free to pause the video and give this one a go yourselves. So I'm just going to keep doing the same method. I'm going to break it down into the product of its prime factors. So I'm going to do 2 and 18, 2 and 9, and then obviously 3 and 3. So I've got 2, 2, 3, and a 3. 102, 2 and 51, 3 and 17. Now 17 itself is a prime number, so that's fine. It looks like I've not broken it down fully, but if you've got to just prime numbers left, that's it. In this case, as you can imagine, I would definitely rather not have to write out the 102 times tables and the 36 times tables. Especially without a calculator. If it is non-calculator, that would be a lot of work. Okay, so I've got that exact same thing listed here. So the ones they have in common is we've got a pair of 2s. So I'm going to put 1, 2 in the middle. We've also got a pair of 3s. So I'll put that in the middle. And then the rest of them, we've got a 2 and a 3 for 36 and a 17 for 102. So the lowest common multiple is all of them times together. So 2 times 2 times 3 times 3 and times 17. Now, I'd imagine this could be more likely to be a calculator one because of the 17, but I guess technically you could use column multiplication if you needed to, but I'm going to put it in the calculator. And that actually gives me 612. So again, imagine writing out the 36 times tables, which we don't really know off the top of our heads, up until 612. Personally, yeah, I would definitely rather not do that. That would be a lot of work. Okay, so same as we saw in the other video with highest common factor is they might actually give you 3 numbers if they want to make it harder. So we're going to do exactly the same thing. We're going to find the lowest common multiple of 18, 56, and 126. So I'm going to break them down into the product of their prime factors. So 18 is 2, 3, and 3. 56, break down into 2, another 2, 2 again, and 7. So 2, 2, 2, and 7. And lastly, 126 is 2, and then 7, and 3, and 3. So 2, 3, 3, and 7. Okay, so to break them all down, we've just got 3 numbers now instead of 2. As you can see, I've listed them here. Now, filling out the Venn diagram, obviously now we have a 3-part Venn diagram. I'm going to fill out the middle bit first. So what do they all 3 of them have in common? Well, they all 3 have a 2, don't they? So that goes in the middle. They don't all have another number that's in common. So looking at the 18, we've got 2 3s and so does the 126. So between 18 and 126, I've got 2 3s, okay, because there's 2 pairs and a pair here and a pair here. With 56 and 126, I've got 2 7s, so that's a pair of 7s, so 1 7 there. And then 56 just has 2 2s left over. So that's my Venn diagram. Now, as we said, the lowest common multiple is multiplying all of those together. In this case, though, remember, it kind of looks like I've got 33 there. Obviously, it's not. So just remember that it's 2 3s and not 33. So I've got 2 times 2 times 2 times 3 times 3 times 7, which again I'll put in the calculator, and that gives me 504. Okay, so again, even though it says the lowest common multiple, the key is the word multiple. Okay, multiple is going to be bigger than your biggest number here. Okay, so it was going to be 126 or bigger. So don't think of it as the fact that it's like the smallest number that goes into them. No, that's a factor. The multiples are the times tables. So it's going to be bigger than your biggest number. And obviously in this case, I definitely didn't want to have to write out 3 lots of times tables that I don't know, especially not 18, all the way up to 504. So this is our last question for lowest common multiple. It looks a bit different to the ones we've just done. However, if you have seen the highest common factor video, you'll have seen something similar to this at the end of that one too. So we're given 2 letters here, A and B, which represent bigger numbers, right? They've said that A is equal to 3 squared times 7 and B is equal to 2 times 7 squared. Now, we don't need to work out what A and B actually are as original numbers, okay? That's not very helpful in this case. We're just asked to find the lowest common multiple of A and B. So even though it looks a bit different, it looks a bit more complicated in this format, it's actually easier because if you think about the process we've been going through, we had to break down the numbers into the product of their prime factors, didn't we, using the factor tree? In this case, we've basically already done that for you. These are the prime factors of A and the prime factors of B. So all we need to do is just carry on with that method and just skip straight to filling out the Venn diagram. So the things that they have in common, they both have 1 7 in common, don't they? So I'll put a 7 in the middle, and that's it. So for A, we've got 2 3s left over, and for B, we've got a 2 and another 7 left over. Now, to find the lowest common multiple, we have to multiply together the whole of the Venn diagram, which means we have to do 3 times 3 times 7 times 2 times another 7. And that actually gives me 882. So that is the lowest common multiple for A and B. Again, we don't need to work out what A and B are as original numbers because that would just be going backwards. They've already given us the prime factors, we just need to carry on from that step in the method. And that is it. So now we've covered prime factor decomposition and the highest common factor, lowest common multiple. The last part of this topic is the lowest common multiple, but in the context of worded problems. So it doesn't seem like it's lowest common multiple. They don't mention the fact that it is lowest common multiple, but we can use this working out to solve those problems. So thanks for watching this video. If you found it helpful, make sure to like and subscribe, and definitely leave down below any questions or comments that you might have.